right, let's go ahead and get started. For problem number 1, who can tell me what is the first thing that we need to do in order to be able to solve this equation? What is the first step? Alex? Multiply the ones that are outside the parentheses. Anybody remember what that's called? Distributive property. Yeah, we're going to be distributing. So we're taking the value that is outside of the parentheses and we're going to go ahead and distribute. Remember, that is always your first step. Always the first thing that you check to see if you can do is you take whatever's outside parentheses and distribute it by multiplication to anything inside the parentheses. So that means that we're going to do negative 5 times 3x. We're also going to do a negative 5 times that positive 7. And when we do negative 5 times the 3x, we're going to get negative 15x. When we do negative 5 times 7, we're going to get negative 35. Then we still have all the rest of this material. We still have that plus 22 plus 9x is equal to negative 37. Okay, from here, what is the next step that we are supposed to do? Trang? Combine our like terms. We identify if there's any like terms on the left side that can be combined and any like terms on the right side that can be combined. If we look at the right side is just a single number. It's just negative 37. There's nothing to simplify here on the right side. But we do have material on the left side that can be simplified. We can start with the variables. We have a negative 15x and a positive 9x. So we can rewrite that so that they're side by side. Negative 15x plus 9x. And when we work that out, that's going to give us a negative 6x. We also have constants, a negative 35 and a positive 22. A negative 35 plus the 22 is going to come out to a negative 13. So we would write minus 13. All of that is still set equal to negative 37. Okay, we've gone ahead and simplified things. Usually our step 3 would be to move variables to just one side, but right now we already have it where variables are just on one side. So we're pretty good to go from there. Then we would move on to that step 4. Step 4 would be to what? What are we going to do from here? Yo-chan? Add 13. We're going to add 13 to both sides. We identify the constant, and in this case, the constant is that negative 13. And we're going to do the inverse of it, which is to add a 13. That way we can go ahead and cancel the 13s out on this side. We're still left with a negative 6x is equal now to a negative 24. Last step, Armando. Very good. We're going to divide by negative 6 on both sides. And at the end, we'll get that x is going to be equal to a positive 4. Everybody should have gotten positive 4 as their answer. Okay? That is a very time-consuming, long, drawn-out multi-step equation. But you won't have most of them like that. You might have one like that on a quiz, but majority of them are going to be a little bit simpler. But if you can do the long, drawn-out ones, then you can do the really simple stuff too. Okay? Number 2, problem number 2. Again, first step is to always see if you can distribute, which we can. We have that value of a positive 3 that can be distributed to the 4x and to the negative 5. So we can do 3 times 4x and 3 times negative 5. 3 times 4x is going to give us 12x. 3 times that negative 5 is going to give us negative 15. We still have this plus 18 that comes down equals a negative 4 plus 5x minus the 7. Okay, from here we now move on to combining those like terms. We do have, on the left side, we have only a single term of x, so we can just write that as 12x. On the right side, we also only have a single term of 5x, So we can just write a positive 5x. Okay, now I focus on my variables, my constants. On the left side, I have a negative 15 and a positive 18. If I do negative 15 plus the 18, that's going to come out to a positive 3. So on the left side, you should have 12x plus 3. On the right side, we have a negative 4 and a negative 7. If we were to go ahead and do negative 4 minus 7, that comes out to a negative 11. So on the right side, you should see 5x minus 11. From here, this is when we start having the idea of variables on both sides. You are not allowed to have variables on both sides. You need to move one of them over to the other side. So in this case, I'm going to go ahead and subtract a 5x from both sides because I want to move the entire variable. Remember, if I'm wanting to keep the variable where it is and just get rid of the number that is attached to it, that's when it's division. But when you want to move an entire term, terms get moved from one side to the other through addition and subtraction. Simplifying terms is through multiplication and division. Okay? So here, if we do 12x minus the 5x, 12x minus 5x is going to come out to 7x. So we now have 7x. We still have this plus 3, and it's now set equal to a negative 11. That minus sign has to come down and act now like a negative sign. So we get a negative 11 here. From there, it's just a two-step equation. We would subtract 3 from both sides. That's going to leave us with 7x is now equal to a negative 14. Our last step is to divide both sides by the 7, and we'll get x is equal to a negative 2. So based off of what we just did here, what I want you guys to do is there's 2 more problems below this. I want you guys to try these out and write down some observations. What did you notice happened when you solved the problem? And what do you think that that means in terms of the solution? So go ahead and work those 2 problems out. You've got one on the back or on the front and another one on the back. Just problems 1 and 2, and see if you can figure out what that means in terms of solutions as far as the solution goes. All right, so who can tell me some observations that they made from problem number 1? When they started solving for problem number 1, what did you notice happened? Yes. Anybody want to share what they noticed happened? Okay, how about we pause for a second then and you guys talk amongst each other and then maybe you'll feel more comfortable? Why don't you talk amongst each other? All right, now that you guys have discussed, who can tell me what happened when we solved in problem number 1? What happened? Come on, guys. Alex, what happened? Why do you say no solution? Okay, so when you subtracted, when you moved variables from one side to the next, that's one thing that's noticed. Hey, if I subtract a 6x from this side, and then I subtract a 6x from this side, the x not only disappears on the right, but it also disappears on the left, right? 6x minus 6x, there's no more x's, okay? So observation number 1, the variable cancels out. It cancels out completely. What's another thing that you notice then? Okay, I cancel out my variables. I'm left with negative 9 is now equal to 5. What do you notice about that? Well, okay, you can't solve anymore. Can't be solved anymore. What did you notice, Nicholas? They're not equal. Okay, the values that are remaining are not equal. Okay, let's talk about that then. Okay, the numbers remaining are not equal. So what do you think that that means then? If you canceled your variables out, like the variables are completely gone, and you're left with a statement that is not equal, what do you think that means about the solution? Is there a solution? No. There is absolutely no solution in this case. Okay? So we can write that down. There is no solution here. The variables are gone, and we're left with an unbalanced result. -9 does not equal 5. What about with problem number 2 then? When we did the same exact thing, what happens again here? If we were to, first of all, how do we move the variables from one side to the next? What are we going to have to do? Are we going to subtract or add what? We're going to add, right? We're going to add 2x to both sides. That's going to cancel it here. But if I add 2x to this side, oh, it cancels it here as well. So again, we're noticing the same pattern. Cancel the variables completely. The variables are completely gone. Okay, what's remaining then here? We canceled out the variables, so what's left over here? 8 equals 8. Okay, in this case, we are left with something that the numbers that are remaining are equal. So what do you think that means for the solution? Alex? There's infinite possibilities. Okay, if some of you are smart enough to read ahead in the notes, you probably would notice that there are 3 types of solutions, right? There's the type that we've been working with all the time, where when you solve, you get x equals some kind of number. That's called a one-solution equation. Then what we just saw in the previous problem is no solution. When we solve, the variables completely cancel each other out because they're identical variables on opposite sides of the equal sign. So if they're identical and they're on opposite sides of the equal sign, then there's nothing you can do. It's going to cancel each other out when you move one to the other. And then what you're left with is unequal values. Those numbers do not balance each other out. That means that there's no value you could substitute in for x that's going to make that equation work. Nothing will ever work for that equation. Then you've got this example where, again, the variables cancel each other out when you're trying to balance the equation, and you're left with a number that is equal to itself. In that situation, that means that every single number that you choose and substitute it in for x will work. Every single value. Doesn't matter. You can plug 0 in. It's going to work. You can plug -5 in. It's going to work. You could plug 1,268.753 in. It's going to work. There is an infinite possibility of solutions. Every single number works. So we call them 2 different things. We call it infinitely many solutions or infinite solutions, or you can say all real solutions. There's 2 ways that you can call it. Infinite solutions or infinitely many, or all real solutions. Every number that you substitute in will work in that situation. Eob. Oh, you're just stretching? Playing with your hair again? All right. So with that in mind, work out these 3 problems and identify for me, is it a one solution, no solution, or infinitely many solutions? If it is one solution, what is the solution going to be? Go ahead and work through those. All right, for problem number 1, real quick, you would distribute 2 times x and 2 times -5. 2 times x is going to give you 2x. 2 times -5 is going to give you a -10. On the other side, you would still have it saying that it's equal to 5x plus 23. You would then go ahead and I would subtract a 2x from both sides. That's going to leave you with a negative 10 is now equal to 3x plus 23. You would then subtract 23 from both sides. That's going to leave you with a negative 33 is equal to 3x. Your last step would be to divide both sides by 3, and you're going to get that x is equal to a negative 11. So that is one solution. Problem number 1 was a single solution problem where x was equal to a negative 11. For problem number 2, again, you would distribute the 3 times x and 3 times 1. 3 times x is 3x. 3 times 1 is a positive 3. You still have this minus 5 equals 3x minus 2. You would then go ahead and subtract 3x from both sides. The x's are going to cancel each other out, and you're left with a positive 3 minus 5 on the left side and a negative 2 on the right side. If you go ahead and simplify this 3 minus 5, that gives you negative 2, which is equal to negative 2. So your variables have completely canceled out. You are left with a set of values that are equal to each other. That means that this is infinitely many solutions for problem number 2. So you should have gotten infinitely many solutions for problem number 2. For problem number 3, there is no distributive property, but you can combine like terms. We can combine negative 3x minus the x together, and that's going to come out to a negative 4x. We can also combine a negative 2x and a negative 2x together. That will also come out to a negative 4x, but we still have this plus 7. So we have negative 4x is equal to negative 4x plus 7. I'm sure you can see where this is going, that if you add the 4x to both sides, you're going to wind up getting these canceled out, which means it's a 0. And these are going to cancel out, but we still have a positive 7 on that side. 0 obviously does not equal 7, so this is going to be one of those no solution kind of problems. Okay, make sure that you're getting onto those IXLs. You have 3 IXLs, one of them which is just identifying the number of solutions, either one solution, no solution, or infinitely many. And then you've got one IXL that's on multi-step equations and another IXL on variables on both sides. Go ahead and get those done.